The Fourier transform f of t of x of t equal to x of omega integration minus infinity infinity x of t e power minus j omega t dt. Inverse Fourier transform I of t equal to x of omega equal to x of t equal to 1 by 2 pi integration of minus infinity infinity x of omega e power j omega t d omega. Dirichlet conditions of Fourier transform. For existence of Fourier transform is defined for all stable signals. Integration of minus infinity into x of t dt less than infinity. Joint signals which are neither absolutely integrable nor square integral or infinite interval can be considered to have Fourier transform if impulse functions are permitted in the transform. F of t have a finite number of discontinuities and finite number of maxima and minima within any finite interval. Linearity a into x1 of t plus b into x2 of t equal to a into x1 of omega plus b into x2 of omega. Time scaling 1 by modulus of a x of f by a 1 by modulus of a x of omega by a. Time reversal x of minus t x of minus f x of minus omega. Time shifting x of t plus or minus t naught e power plus or minus j 2 pi f t naught x of f nothing but e power j plus or minus j omega t naught x of omega. Frequency shift x of t e power plus or minus j omega naught t equal to x of f minus plus f naught or x of omega minus plus omega naught. Differentiation in time d by dt of x of t j 2 pi f x of f d by dt of x of t j omega x of omega. Frequency differentiation minus j 2 pi x of t gives you d by df of x of f. Remember, minus jt x of t is nothing but d by d omega of x of omega. Once again, frequency differentiation minus j 2 pi f x of t is nothing but d by df of x of f, whereas minus jt x of t is nothing but d by d omega of x of omega. Convolution in time x of omega h of omega. Frequency convolution 1 by 2 pi into x1 of omega convolve with x2 of omega. For frequency convolution in x1 of t into x2 of t is nothing but 1 by 2 pi x1 of omega convolved with x2 of omega x1 of f into x2 of f. Integration of minus infinity to x of tau d tau is nothing but x of f by j 2 pi f plus 0.5 x of 0 del of f is nothing but x of omega by j omega plus pi into x of 0 del of omega. Parseval's theorem. Integration of minus infinity to infinity x square of t dt is nothing but integration of minus infinity to infinity x of f square df 1 by 2 pi integration of minus infinity to infinity x of omega square d omega. Now e power minus a t u of t a greater than 0 1 by a plus j omega e power a t u of minus t a greater than 0 1 by a minus j omega del of t is nothing but 1. A constant a is nothing but a into del of f or 2 pi a into del of omega. A rect t by tau equal to a t sinc f t or a t sinc omega t by 2 e power minus a modulus of t 2a by a square plus 4 pi square f square 2a by a square plus omega square e power minus a t square root pi by a e power minus pi square t square by a root pi by a e power minus omega square by 4a. The Fourier transform of signum functions Sgn of t equal to 1 by j pi f that equal to 2 by j omega u of t 1 by j pi f plus 0.5 del of f that is nothing but 1 by j omega plus pi into del of omega cos omega naught t del of f minus f naught plus del of f naught plus f naught by 2 that is nothing but pi into del of omega minus omega naught plus del of omega plus omega naught sin omega naught t del of f minus f naught minus del of f naught f plus f naught by 2j that is nothing but pi by j del of omega minus omega naught minus del of omega plus omega naught. T power n e power minus a t u of t n factorial by a plus j 2 pi f whole power n plus 1 is nothing but n factorial by a plus j omega whole power n plus 1. Hilbert transform h of x of t equal to x of t convolution with 1 by pi t. Hilbert transform provides a phase shift of minus 90 degrees to all signals. Signals and its Hilbert transform have same energy spectral density or power spectral density and autocorrelation. Impulse response h of t equal to 1 by pi t h of j omega equal to minus j signum of omega that equal to minus j for omega greater than 0 j omega less than 0. Fourier transform of a real signal is always even conjugate in nature. Fourier transform of real and even signals is purely real and even. Fourier transform of real and odd signals is purely imaginary and odd. Shifting in time domain only changes the phase spectrum of signal. Compression in time domain leads to extension in frequency domain and vice versa. Time differentiation property is only valid if f of t tends to 0 as modulus of t tends to infinite. F of omega whole square is energy spectral density or of signal for energy signals. Fourier transform of discrete time signals dtFft of a periodic signal x of n is given by x of e power j omega equal to sigma n equal to minus infinite to infinite x of n e power minus j omega n inverse dtFt of x of e power j omega is given by x of n equal to 1 by 2 pi integral of 0 to 2 pi x of e power j omega e power j omega n d omega. dtFt is always periodic with period 2 pi. Properties of DTFT. Okay, suppose time shifting a periodic signal x of n minus plus n naught e power minus plus j omega n naught x of e power j omega. Time expansion xk of n equal to x of n by k if n is multiple of k, 0 otherwise. X of e power jk omega. For Fourier transform, a periodic signal, that is the convolution x of n convolution with y of n, differencing a periodic signal x of n minus x of n minus 1, that is nothing but for Fourier transform 1 minus e power minus j omega x of e power j omega. Accumulation, a periodic signal sigma k equal to minus infinity x of infinity to n x of k, whereas Fourier transform 1 by 1 minus e power minus j omega x of e power j omega. Differentiation in frequency n into x of n j into for a periodic signal for Fourier transform j into d by d omega of x of e power j omega. Parseval's relation, a periodic signal sigma n equal to minus infinite to infinite x of n whole square for Fourier transform 1 by 2 pi integral of 0 to 2 pi x of e power j omega whole square d omega. X of n implies x of e power j omega, y of n implies y of e power j omega. Discrete Fourier transform DFT of a periodic x of n with period n is given by x of k equal to sigma n equal to 0 to n minus 1 x of n e power minus jk of 2 pi by n into small n. K varies from k equal to 0 to n minus 1. Inverse DFT of periodic x of k with period n is given by x of n equal to 1 by n sigma k equal to 0 to n minus 1 x of k e power jk 2 pi by n into small n. DFT pairs x of n equal to L of n for 0 less than or equal to n less than or equal to capital N minus 1, x of k equal to 1, 0 less than or equal to k less than or equal to n minus 1, x of n equal to 1, 0 less than or equal to n less than or equal to n minus 1. దానికి పేరు ఏమంటే x of k equal to n into del of k 0 less than or equal to k less than or equal to n minus 1. x of n equal to e power j 2 pi n k naught n కి దానికి DFT పేరు ఏమంటే x of k equal to n into del of k minus k naught. DFT pair of x of n equal to cos of 2 by k naught n by capital N, that is nothing but x of k equal to n by 2 into del of k minus k naught plus del of k minus n minus k naught, where 0 less than or equal to k less than or equal to n minus 1. Properties of DFT, periodicity. DFT f of n f of k equal to f conjugate of n minus k, time reversal of sequence x of minus n of n equal to x of n minus n. Circular time shift x of n minus l is nothing but x of k into e power minus j k l by capital N. Circular frequency shift x of n into e power j by j 2 pi l n by capital N is nothing but x of k minus l capital N. Complex conjugate property, x conjugate of n is nothing but x conjugate of minus k. Circular convolution x2 of n, circular convolution x2 of n equal to x1 of k into x2 of k, f of n, circular convolution h of n equal to sigma k equal to n minus 1 f of k h of n minus k in n. Multiplication of two sequences x of n into x2 of n equal to 1 by capital N into x1 of k convolved with x2 of k. Parseval's relation sigma n equal to n1 0 to n minus 1 x of n square equal to 1 by n sigma k equal to 0 to n minus 1 x of k square. Remember, circular convolution can be found using linear convolution method. Is divided the result of linear convolution into two parts such that first part has n samples and then we add corresponding part in order and write as a circular convolution. Here n is number of samples in each signal. Given two signals f of n and h of n, each consisting of n samples, if we zero pad each of the signal with n zeros and carry